Dear learners, greetings. Since previous two sessions, you have seen the uses of two uses of normal probability curve. First use was there, scores were given and you were required to find out the percentage of the cases. In the second use, percentage of cases were given and you were required to find out the scores. Now, let us talk about the third use of normal probability curve today, and this is entirely a different use. So, what is this? It is about to separate a given group into subgroups according to capacity when the trait is normal distributed. That is, a group is given and you are required to classify that particular group into subgroups. So, here also, I mean, assuming that the normal probability is there and the range of ability, I mean, we are required to put equal. So, by that way, normal probability curve is very important, it is very useful. So, how to do it? Let us take one example and accordingly we will do it. So, example is written on the slide, you see. An entrance exam was administered on 100 students. We wish to classify students into 5 subgroups A, B, C, D and E according to ability, with the condition that range of ability must be equal in each subgroup. On the assumption that trait is normally distributed, how many students should be placed in subgroup A, B, C, D and E? So, let me first explain the problem. 100 students were administered some entrance test and all the 100 students we want to classify into 5 subgroups, that is A, B, C, D and E, and this classification is required to be done according to the ability, with the condition that the range of ability must be equal in each subgroup. And you have to assume normality. Now, you have to calculate how many students should be placed in subgroup A, B, C, D and E. In this type of problem, remember that first we locate the mean. After locating the why we locate mean? Because mean is the point which divides this whole curve into two equal halves. So, the moment we locate the mean, it becomes easy for us to divide the whole curve into various groups. So, here remember we have to classify the students into 5 subgroups. Now, I wish that you people go back and rebrush your memories and remember, when the characteristics of normal probability curve was told to you, it was told that the practical area which is there in the curve is from plus 3 sigma to minus 3 sigma. It is 99.74, that is approximately 100%. I mean, beyond 3 sigma, positive sigma, or beyond minus 3 sigma, I mean, the percentage is very less, so we can ignore them, we can neglect them. So, the practical area in the normal probability curve varies from plus 3 sigma to minus 3 sigma. Now, see this case. If you see, move mean to 3 sigma positive side and if you move mean to 3 sigma negative side, so total you have to move 3 sigma plus 3 sigma, that is you have to move 6 sigma. Now, you are required to classify the group into 5 subgroups, that is 6 sigma will be divided by 5, so 1.2 sigma. Now, you have to classify all the students into 5 subgroups. So, since you are required to do it, that range of ability must be equal in each subgroup, it means every subgroup will have a space of 1.2 sigma. This is the most important point that is required to be considered in doing such type of problems when you are required to classify the whole group into various subgroups. Let me repeat. You are moving 3 sigma towards positive side, you are moving 3 sigma from mean towards negative sign. So, total you have moved 6 sigma, you will divide this 6 sigma by 5. So, each subgroup will have a space of 1.2 sigma. Keeping this in view, let's do it. Let's proceed and do the problem. So, this is the case. This is the mean. So, 0.6 sigma and this is 0.6. So, this is the first group. Similarly, 0.6 to 1.2, that is 1.8, and from 1.2 to 3. Similarly, here you will be 1.8 and here it will be 3. So accordingly 1 group, 2 group, 3 group, 4 group, 5 group, that is 5 groups will be there, and every 5 subgroups will be there, and every subgroup will have a space of 1.2 sigma. Now, this is the mean point and this is 1.8 sigma. So, first find out this area. You will find this area as 46.41%. So, 46.4%, 1% will be subtracted from 50. So, finally, you will get A as 3.59. So, this particular, this is A. So, it shows that out of 100 students, almost 3.59, that is equivalent to 4, you have to keep in group A. Let me repeat what you have done. In fact, what I have said earlier, that every subgroup will have a space of 1.2 sigma. So, this particular group, its space is from 1.8 sigma to 3 sigma. So, first you locate this area. This area has been calculated as 46.41%. Now, you have subtracted 46.41 from 50. So, you have got 3.59% area. For B group, so for B group, what you will do? Already you have calculated this area, this much, as 46.41. So, this particular area is what? 22.57%. So, you will subtract 22.57 from 46.41. So, finally, you will get 23.84%. This is the important point, and let me repeat it. For the B group is this. Already you have found out this area as 46.41. So, you will proceed and you will subtract 22.57, that is from mean to 0.6 sigma, it is 22.57. So, you will subtract and finally you will get 23.84%. For C, area is equal to 22.57 plus 22.57, and why we have done it? Because we are required to find out this. So, this is C. So, A, B and this is C. So, C case is different. Here instead of subtracting, we have to add, because these two smaller group are there and we will combine them. So, finally, you will get 45.14. So, for 1 it is 3.59, for second it is 23.84, for C it is 45.14. Now, let us proceed and find out the area for D. So, area for D, again this whole area, that is from mean to 1.8 sigma, you know it is 46.41, and the moment you will subtract from mean to 0.6 sigma, that is 22.57, so you will get 23.84%. So, for B and D the case will be same, that is 23.84%. Now, let us proceed to the last case, that is for E. So, E case and A case will be almost same, that is 3.59. So, remember, for A you were required to calculate in the same way as you are required to calculate for E. So, A and E both 3.59%, B and D both 23.84% and C 45.14%. Now see, there were 100 students. So, 100 students A, B, C, D, E, remember they are students. So, you can't say 3.59, I mean you have to take it as 4. Come to B 23.84, so you will take 24. Come to C, it is 45.14, so you will take 45. Come to D, again you will take 24. So, now find out, add 4 and 4 8 and 5 13 and 4 17, 1 2 1 3 3 4 7 7 2 9 9 7. So, in here almost 3 cases will be there. So, in a nutshell, 100 students were there and you were required to classify them into 5 subgroups. So, what you did in fact, first of all you saw you drew the normal probability curve, and the moment you drew the normal probability curve, you know the characteristic of the normal probability curve, that the practical area which lies in the normal probability curve is from plus 3 sigma to minus 3 sigma, that is total 6 sigma. So, 6 sigma will be divided into 5 groups, and accordingly everywhere you will get 1.2 sigma, and accordingly you have to proceed. So, locate 1.8 sigma, locate the area, subtract from 50. So, A you will locate, similarly uh, B you have to subtract, I mean mean to 1.8 sigma, you have to subtract mean plus 0.6 sigma from mean 1.6 sigma, and finally you will get B. Similarly, you will proceed. C is a different case. Instead of subtracting, you will be doing the addition, and for D it will be in the same way as you have done for B, and for E in the same way as you have done for A. So, this is how we do. So, this is a very unique use of normal probability curve, in which uh, a particular group is required to be classified into various subgroups based on equal ability, based on normality, and you can do that. So, let us proceed to another problem, and again this is a very interesting case, and in the same way as you have done in the previous problem, same you can go ahead with this problem. This is a little bit tough problem, but it is very interesting. The problem says, and creativity test was administered on a group of 800 students. We wish to classify students into 8 subgroups A, B, C, D, E, F, G and H according to creativity, with the condition that range of creativity being equal in each category. So, on the assumption that rate is normally distributed, then how many students should be placed in subgroup A, B, C, D, E, F, G and H. So, remember in the previous case 100 students were there and you were required to classify all the 100 students into 5 subgroups. Here what is the case? Number of students is more, 800 students, and instead of classifying them into 5 subgroups, you are required to classify them into 8 subgroups. So, remember, proceed in the same way. You see, mean plus 3 sigma and mean minus 3 sigma. So, total movement in the curve is 6 sigma. So, here we have since 8 groups. So, now what you will do? You will divide 6 sigma by 8, and the moment you will divide 6 by 8, what you will get? Remember, 8 7s are 56 and 8 5s are 40, that is every subgroup will have an area of 0.75 sigma. So, in the previous problem every subgroup had an area of 1.2 sigma, but here in this case every subgroup will have an area of 0.75 sigma. Accordingly, draw normal probability curve and move. So, for the this is the case, So, mean. Now, there are so many groups, so accordingly proceed. So, 0.75 plus 0.75 plus 0.75 plus 0.75. So, 0.75, 0.75, 0.75 and 0.75. Similarly, here also 0.75, 0.75 we have to. And then A. So, A, B, C, D, E, F, G and H. So, 8 groups will be there. So, remember that for A, you have to subtract 2.25 sigmas, I mean the area that you have got from the table, you have to subtract from 50. So, it is a very small amount, 1.22%. For B, the moment you will subtract, you will get 5.46, and similarly for C it is 15.98, for D it is 27.34, for E again it is 27.34, and then for F it is 15.98, for G it is 5.46, and finally it is 1.22 for H. So, for A and H same, that is 1.22, for B and G same, that is 5.46, for C and F it is 15.98, and for D and E it is almost 27.34. Now, accordingly you divide 800 into this. So, you will get finally that how many students should be there in every subgroup. So, remember in a nutshell what should be remembered? See how many groups are there, divide that number of group, 6 sigma divide by that number of group, you will get the required area for every group, and accordingly consult the table, find out the area and do the needful. Let us take another problem. It is again a little bit more difficult problem. There is a group of 1000 individuals which are required to be divided into 10 subgroups. So, instead of 8 subgroups, here in this problem we have 10 subgroups. So, A, B, C, D, E, F, G, H, I and A, B, C, D, E, F, G, H, I and G, that is 10 groups are there. So, uh, what we will do? So, 3 sigma and 3 sigma, total 6 sigma, 6 sigma will be divided by 10. So, 0.6 sigma, accordingly we have to divide, and the moment you will proceed, you will find this is the required way. So, this is a very unique application of normal probability curve. By the characteristics of normal probability curve, by knowing the peculiarities of the normal probability curve, definitely you can divide a group into various subgroups. So, this was the last class of this course, and dear learners, I am highly grateful to you for staying with us. I am quite sure now today you people are feeling much relaxed because you have completed a very important course, that is advanced statistics in education. And in the beginning I have said that after completing this course, so many capabilities will be developed in you related to data handling, related to the analysis of the data, related to coming to some conclusion based on the data, and I am quite sure you people have developed those capabilities. So, thank you very much for being with me. Thank you.